So our last video had us find the domain and range of individual ordered pairs. So we listed the x values for the domain, the y values for the range. So what makes this one a little bit different is we don't have individual x values. We have a continuous segment right here. So we are going to find the domain based off of the x values, just like we did before. But we're going to take a look at that. So the domain is the x values, and what you want to think about is, kind of left and right. This is your x-axis. How far to the left does our graph go, and how far to the right does our graph go? You can also take your graph and kind of connect it to the x-axis. So on the left, we can see it goes down to a 1. There's nothing to the left of that, so 1 is the smallest value of your domain. If you go to the right, to the other end at the 4, and connect to your x-axis, we can see our graph is everything between 1 and 3. So we're going to say our domain, we start with the 1, is less than or equal to x, because x is our domain values, which is less than or equal to 3. And that's giving us an entire interval for all of our possible domain values, because, your input could be 1.5, and I can see on the graph, oh yeah, well 1.5 is right here, and the graph is there. It could be 1.99, which is right here. We do have our graph at 1.99. All right, so our range, same idea. We are going to find, this time for the y values, how low does the graph go? Because your y-axis goes up and down like this, so how low does the graph go? How high does the graph go? So you can, this time, connect it to the y-axis. So I'm going to start on the left here. I can see, that 2 is the lowest that our graph goes. And even if I draw the line all the way up, there's nothing lower than that 2. And it goes all the way up to here. And if I connect to the y-axis, that's a 4. So the entire graph is between the 2 and the 4. And the way that we write that is we say that our range is 2 is our smallest number, is less than or equal to, this time we're going to say y is less than or equal to 4. So that is our kind of interval notation for domain and range. We do have to tell if the relation is a function, so I wanted to show you guys this thing called a vertical line test. I am going to see if I can erase some of the stuff I just wrote. Let's see. Nope. Okay. All right, there we go. Got rid of the lines. So to tell whether or not the relation is a function, we can do this thing called the vertical line test. What the vertical line test is you pass a vertical line over your graph and see if you hit your graph in more than one spot. So if you notice, I can draw a vertical line, these are vertical line tests. I'm just kind of imagining me passing a vertical line from left to right over the graph. Did it ever hit that line in more than one spot? If it did not, that's a good thing. That means it passed the vertical line test, and that makes it a function. So is it a function? Yes, it is. And then what's our reason? Well, it just passed the vertical line test. I'm just going to say VLT, but actually let's write that out so you guys have it in your notes. That's the vertical line test. Okay. So, next one, now that we kind of have the idea, they go a little bit faster. So our domain, we're going to go to the left side of the graph and see where it hits the x-axis. So I can see it's hitting it at a -4. And I don't have anything to the left of the -4. There's nothing over here. So our graph starts at -4, and it goes all the way over here to a +4. So our domain is everything between -4 and +4. So we say -4 is less than or equal to x, which is less than or equal to 4. We can find our range also. Again, this time pay attention to the y-axis. How low does your graph go? I can see it goes all the way down to a -4. And how high does it go? Well, it goes all the way up there to a +4. So our range goes from -4 to +4. So we'll say -4 is less than or equal to y, which is less than or equal to +4. make sure you're very careful that you're using an x for your domain and a y for your range. All right, so is this relation a function? So we can do that vertical line test again. You draw a vertical line through your graph, and if it ever crosses your graph more than once, it is not a function. So, okay, first line we drew, there you go. See how it's crossing it twice? That's enough to say, nope, it's not a function, it failed the vertical line test. In this example, any vertical line we draw, though, you can see every single one is crossing it twice. But if you can get a single vertical line to cross twice, that means it is not a function. So is it a function? No, it's not, because it failed the vertical line test.